to discuss the tree data structure. First of all, we see why should we use tree data structure. Already we have implemented array data structure and linked list data structure. Array is quite an efficient way to store and retrieve the data, but the problem with array is that for array we need to allocate the consecutive memory. That's the first problem. And the second problem is we have to allocate the memory in advance. So sometimes we have surplus memory that's not used, that's called, you can say, memory is wasted, and sometimes we run short of memory. So array is not good in memory management. So to efficiently manage the memory, we started using linked list. So linked list is quite good at memory management, but linked list is quite slow because in linked list we have only the address of the first head or the tail node, and we have to traverse all the linked list to find any desired data or any desired element. So linked list is quite slow. So to solve that problem of access, so to solve the access problem, we use tree. Tree is quite a beautiful way to arrange the items so that they are in our access. So you can understand the concept of tree with nature. Like, just take an example of an orange or apple tree. An apple tree can have thousands of apples. Say an apple tree has 1,000 apples. If we arrange those apples in a linear way, then to find any apple will take n steps. So you will have to write a loop that will run n times to traverse all the apples to find your required apple. So the complexity of access for any apple in an apple tree, in an apple you can say stock which has apples arranged in a linear way, will be O of n. But in linear way, but in tree form the apples are arranged in such a way that any apple is quite in your access. So this is the beauty of nature of arranging the fruits on a tree. So we derive the idea from that you can say from the nature, and we use the tree data structure like this. This is a tree data structure, and if you want to access this node I, you will come here, 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 and just in 4 steps you will reach here. Otherwise, if it had been in a linear way, you had to cover all the n nodes. So this is the concept of tree, and that's why we use the tree data structure. And now we see some terminology that is used in a tree data structure. Root is a node that is the topmost node, that we have the address of this node. And parent, root is parent, and these two are children. Similarly, node A is parent of C and D, and C is parent of H and I. And children, the same concept. No, A and B are children of root. Similarly, C and D are children of A, and similarly E, F, G are children of B. And the concept of sibling is that the children of the same node. Like here, E, F, G are siblings because they have the same parent B. And the concept of ancestor is like L has all these ancestors. K is ancestor of L, and then F is ancestor of L, and then B is ancestor of L, and then root is ancestor of L. So all the parents and the parents of parents are the ancestor of the given node, and descendants are basically the children, and the children of children are the descendant. Like in this case, root has the children node A, and all these are again the descendant of root. And finally, subtree is a small tree within a bigger tree. Like this is a big tree, and it has many small trees. Like this is a small tree, and this is a small tree. So this is, you can say this is subtree A, this is subtree B, and again this is a subtree. So these are some basic terms and why should we use tree data structure. In the next lecture we will discuss binary tree, binary side tree, and the complexity of those trees, and then we will do some coding and traversal of the trees. So stay tuned for the next lectures.